The hypothesis that all the continents are moving very slowly across Earth's surface. Continental drift. Continental drift is the movement of Earth's continents over time due to plate tectonics.
Imagine trying to move a heavy piece of furniture across a carpeted floor where it seems like you're making little progress at each push. This slow and steady movement mirrors the way continents drift across the Earth's surface, inching forward at a pace that is almost imperceptible. Just as each nudge of the furniture gradually shifts its position over time, tectonic forces beneath the Earth's crust continuously nudge continents along their paths, causing them to drift slowly across the planet's surface.
The supercontinent that broke up 200 million years ago into the continents we see today. Pangaea. Pangaea was a massive landmass where all the Earth's continents were once joined together before drifting apart due to plate tectonics.
Imagine trying to fit a massive jigsaw puzzle together, only to find that the pieces don't all fit just right over time. This is similar to how the supercontinent Pangaea once existed as a giant landmass and then gradually broke apart into the continents we recognize today. Just like the jigsaw puzzle pieces that shift and separate to form a new picture, Pangaea's landmasses drifted and rearranged themselves due to tectonic forces, ultimately creating the diverse world map we see now.
A long mountain range on the seafloor formed by lava eruptions through Earth's crust, mid-ocean ridge. It is where tectonic plates move apart, allowing magma to rise and create new seafloor.
Imagine you're trying to bake a loaf of bread, and as it rises, the dough splits in the middle, revealing a stretch of raw dough as it expands. Similarly, a mid-ocean ridge forms when molten rock from beneath the Earth's crust pushes upward, causing the seafloor to spread apart and create a mountain range. Just as the dough surfaces and stretches apart to reveal the soft interior, the Earth's crust splits and allows lava to emerge and solidify, forming new oceanic crust at the mid-ocean ridge.
The formation of new seafloor by magma at a mid-ocean ridge, seafloor spreading. It is a process where new oceanic crust forms as magma rises and solidifies at mid-ocean ridges, gradually pushing older crust apart.
Imagine you're trying to fit a growing collection of books on a shelf that's already full. This is like seafloor spreading, where new seafloor is created by magma at a mid-ocean ridge, pushing the older seafloor aside. Just as you need to make space on the shelf by shifting books to accommodate new ones, the Earth's plates are moved apart by the formation of new seafloor, with the mid-ocean ridge acting as the point where new books, magma, are added, and the shelf, ocean floor, expands.
The theory that Earth's crust is made of moving plates, plate tectonics. It's the idea that Earth's surface is divided into large pieces that float and move on the molten layer beneath them.
Imagine trying to fit a large puzzle together, where each piece doesn't quite lock perfectly with the others, making the whole picture shift as you try to align them. This is similar to Earth's crust, where the puzzle pieces are actually massive plates that float and move over the semi-fluid mantle beneath them. Just like how the movement of one puzzle piece can cause others to shift, the movement of these tectonic plates can lead to earthquakes, volcanic eruptions, and the creation of mountains as they jostle and adjust against each other on Earth's surface.
A deep part of the seafloor where a subducting slab bends down. Ocean trench. An ocean trench is a deep, narrow valley in the ocean floor, formed where one tectonic plate slides beneath another.
Imagine trying to fit a thick blanket into a small, overstuffed closet where you have to push it down into any available space. This is similar to how an ocean trench forms, where one tectonic plate is forced beneath another and bends downward into the Earth's mantle. Just like the blanket being pushed into a cramped space, The ocean trench represents the area where the subducting slab bends down, accommodating the pressure and constraints of the tectonic plates above and below.
The boundary where two tectonic plates move towards each other. Convergent boundary. In simple terms, a convergent boundary is where Earth's plates collide, forming mountains or causing earthquakes.
Imagine two cars on a narrow street, slowly driving towards each other from opposite ends. This scenario is similar to how tectonic plates behave at a convergent boundary. Just as the cars approach one another, potentially causing a collision, or forcing one to rise over the other, tectonic plates move towards each other, sometimes resulting in one plate being forced beneath the other, or causing the ground to crumple and rise, forming mountains or triggering earthquakes.
The boundary where two tectonic plates move away from each other. Divergent boundary. It is where new crust forms as the plates separate.
Imagine you and a friend deciding to rearrange furniture in your living room, each of you pushing a couch in opposite directions. This situation is similar to a divergent boundary where two tectonic plates move away from each other. Just as moving the couches apart creates new space in the middle of the room, the separation of tectonic plates at a divergent boundary allows molten rock from the mantle to rise and create new crust, forming features like mid-ocean ridges.
A break in Earth's crust along which rocks move. Fault. A fault is a crack in Earth's surface where sections of rock can slide past each other, causing earthquakes.
Imagine you're trying to fix a broken zipper on your favorite jacket, and as you pull, the teeth separate unevenly, causing the sides to move apart. This scenario is similar to a fault in Earth's crust, where a break occurs and the rocks on either side shift as if they were the unaligned zipper teeth moving past each other. Just as the zipper teeth misalign and cause the sides to slide, a fault is a break in the Earth's crust, allowing the rocks to move and shift, much like the jacket's fabric moving along a misaligned zipper.
A deep valley that forms as plates move apart. Rift valley. A rift valley is a lowland region formed when Earth's tectonic plates separate.
Imagine you're trying to separate a tightly glued sandwich from its wrapper, and as you pull the wrapper apart, a gap forms between the two sides. This is similar to how a rift valley forms when tectonic plates move away from each other, creating a depression in the Earth's surface. Just as pulling apart the wrapper creates a space between the sandwich halves, the movement of tectonic plates away from each other results in a deep valley forming between them.
A crust plate forced beneath another at a plate boundary. Subduction. Subduction is when one tectonic plate sinks under another into the Earth's mantle.
Imagine trying to fit all your clothes into an already full suitcase. As you push down on one side, something else inevitably gets pushed beneath or squeezed into a corner. This is similar to how, at the boundary between two tectonic plates, one plate gets forced beneath another due to immense pressures. Just as the clothes in your suitcase shift and compress to make room for more, the Earth's crust behaves similarly, with one plate diving beneath another in a process called subduction, where the suitcase is the Earth's crust and the clothes are the tectonic plates adjusting to fit.
The boundary where two plates scrape past each other. Transform boundary. A transform boundary is a place where two tectonic plates move sideways past each other, often causing earthquakes.
Imagine you're walking in a crowded hallway and accidentally bump shoulders with someone walking in the opposite direction. This situation is similar to a transform boundary, where two tectonic plates slide past each other horizontally. Just as the friction and impact from the shoulder bump can cause a brief jolt or stumble, The friction and stress at a transform boundary can lead to earthquakes as the plates grind against each other. In both scenarios, the interaction is characterized by lateral movement and the release of built-up energy, whether it's people brushing past each other or tectonic plates scraping along their edges.
The soft upper mantle layer under lithospheric plates. Asthenosphere. The asthenosphere is a semi-fluid layer of the Earth upon which tectonic plates float and move.
Imagine trying to balance a tray full of dishes on a thick, soft mattress. Just as the tray rests on the mattress, adjusting and sinking slightly based on the weight and balance of the dishes, the lithospheric plates sit atop the asthenosphere, which is a softer, more pliable layer. The connection lies in how both the mattress and the asthenosphere provide a supportive yet flexible foundation that allows for movement and adjustment, with the lithospheric plates moving similarly to how the tray might shift on the mattress.
The movement pattern in a fluid caused by temperature differences within the fluid. Convection current. In simple terms, a convection current is when warmer fluid rises and cooler fluid sinks, creating a circular flow.
Imagine you're in a crowded elevator and everyone is trying to reach different floors. Just like people in an elevator move up and down to reach their desired levels, warm and cool parts of a fluid move in a similar pattern. As the fluid heats up, it rises, similar to people trying to get to higher floors, while cooler fluid sinks, akin to people heading to lower floors. This movement creates a continuous cycle, like an elevator's constant up and down motion, illustrating the convection currents caused by temperature differences within the fluid.
The rigid outer layer of Earth made up of the crust and upper mantle. Lithosphere. The lithosphere is the solid, outer part of Earth that includes the crust and the uppermost mantle.
Imagine you're trying to carry a hard-boiled egg without breaking it. The egg's shell acts like the lithosphere, providing a rigid protective layer that surrounds the softer interior, just as the lithosphere encompasses the more pliable layers beneath it. In this analogy, the egg's shell represents the Earth's crust and upper mantle, which, like the lithosphere, are rigid and protect the dynamic, softer layers below, much like how the shell protects the egg's inside.
The central part of the Earth, below the mantle, is the core. The core is the innermost layer of Earth, made mostly of iron and nickel, and it's responsible for generating our planet's magnetic field.
Imagine trying to reach the toy that has fallen into the deep cushions of your couch. Just like the toy is hidden beneath layers of fabric and padding, the Earth's core is concealed far below the mantle and crust. The couch cushions are analogous to the Earth's layers, with the core being like the lost toy, tucked away deep inside, out of sight, but crucial to the couch's structure and comfort, much like how the core is crucial to the Earth's stability and magnetic field.
The thin, rocky outer layer of Earth, above the mantle, is called the crust. The crust is the hard outer shell of the Earth where we live.
Imagine trying to peel a hard-boiled egg without breaking the delicate white underneath. Just like the thin shell that covers and protects the egg, Earth's crust is the thin, rocky layer that sits above the more robust mantle. The shell is to the egg what the crust is to Earth. Both act as protective barriers that preserve what lies beneath, while being the outermost layer that we interact with directly.
The layer of rock between Earth's crust and core. Mantle. The mantle is a thick layer of rock inside Earth that moves slowly and affects how continents and oceans are shaped.
Imagine trying to keep a sandwich from falling apart while taking a big bite. The way the filling in a sandwich supports and holds together the bread layers is similar to how Earth's mantle functions between its crust and core. Just as the filling stabilizes and gives structure to the sandwich by sitting between the bread slices, the mantle acts as a thick, viscous layer that maintains Earth's structure, sitting between the thin crust above and the dense core below.
Any process that moves Earth's surface to a higher elevation. Uplift. Uplift is the upward movement of Earth's surface, often caused by tectonic forces.
Imagine trying to push a stubborn piece of furniture up a flight of stairs. Just like the effort you exert to elevate the couch to a higher floor, natural processes like tectonic activity push the Earth's surface to higher elevations. In both cases, there's a force working to lift something from a lower position to a higher one. Your muscles for the couch, and tectonic forces for the Earth's crust.
An energy wave caused by an earthquake. Seismic wave. A seismic wave is a vibration that travels through the earth when the ground shakes.
Imagine you drop a small stone into a calm pond and watch as ripples spread outwards from the point of impact. This is similar to how seismic waves behave during an earthquake, where energy is released and travels outward from the quake's origin, much like the ripples from the stone. Just as the stone causes waves in the water, the energy from the earthquake generates waves that move through the Earth's crust, with both scenarios illustrating how an initial disturbance can propagate energy through a medium.
The dense sphere of solid iron and nickel at the Earth's center. Inner core. The inner core is the Earth's hottest part, made of solid metal, which helps generate Earth's magnetic field.
Imagine trying to find a warm spot on a cold winter's day by wrapping yourself in layers of blankets. Just like those blankets create a series of layers to keep you warm, the Earth is composed of several layers, with its innermost layer being the dense sphere of solid iron and nickel known as the inner core. The blankets are analogous to the Earth's outer layers, like the crust and mantle, insulating and protecting the solid inner core, which is akin to your body being kept warm at the center of all those blankets.
A layer of molten nickel and iron that surrounds Earth's inner core. Outer core. The outer core is a hot, liquid layer of metals surrounding Earth's solid inner core, creating our planet's magnetic field.
Imagine trying to bake a cake with a gooey center and a solid crust. Just like that cake, Earth's outer core is a layer of molten nickel and iron that envelops the solid inner core. The gooey, molten part of the cake represents the outer core, which flows around the solid inner portion, much like how the molten metal flows around the solid inner core of the Earth.
The transfer of heat energy from a warmer area to a cooler area in a liquid or gas. Convection. Convection is the process where warm air or liquid rises and cooler air or liquid sinks, creating a cycle.
Imagine you're trying to cool down a hot cup of coffee by stirring it with a spoon. This is similar to how convection works, where movement within the coffee, like that of heat energy in a fluid, transfers heat from the warmer coffee to the cooler room air. Just as stirring the coffee helps distribute the heat more evenly and allows it to cool faster, convection involves the movement of warmer and cooler fluid particles, facilitating the transfer of heat energy from a warmer area to a cooler area in liquids and gases.